Okay guys, today I am going to uh, tell about a linear data structure which is called stack. So in this tutorial you will learn what is a stack and how you can implement it in C++, C, Java and Python. So for these I take help of the programmees.com websites, and you can check out their website also. It is very useful website. And so let's dive into the content. And basically a stack is a useful data structure, and it's just like a pile of books or plates kept on top of each other. So you can see it in picture that a stack representation, like you make a row of books on each one of them, one of each one in each other, and after that it makes a pile, and you can take it as a representation of stack. So the thing you can do with a stack or a pile of books or plates, that you can put a new plate or book on the top, or you can remove the top plate. So like you can do a thing in one place, like the fast in and fast out. So it's basically use the last in first out method, and its property also in short called LIFO. So it's a very useful property, and it's uses in many places. So let's take a look at the stack in programming terms. So stack in programming terms, adding an element in top, it's called push, and removing an element from the top called pop. So it has two methods, push and pop. So like if you initialize an empty stack and there you push an element, it's add, after that you add another element and it also add on the top of it. Now you want to pop, so the top, like you add 3 and want to pop another one, so it will pop the last in element and it will first out. So it's follow the last in first out principle. So now take a look at the stack specification. So a stack is an object, or more specifically a abstract data structure, that allows this operation, like the push operation. It add an element on the top of the stack, and after that we have pop, it remove an element from the top of the stack. After that we have the two boolean properties, it's called is empty, like it's check if a stack empty or not. After that we have the full is full, like it's check this stack is full or not. And after that we have the peak. This property give us the top element value, like without removing it. So let's take a look how a stack works. So the basic algorithm is that we first initialize a stack using array or a linked list. You can use any of the data structure to implement a stack, and it's very useful, like if you use linked list, because array takes much space than a linked list. And so basically we initialize a pointer called top to keep track of the top element in the stack, and when we initialize this, so the value of the top is -1 because the stack is already empty. So after we initializing, we push an element. So after pushing an element, the increase of the value of top, and now top will be 0 and new element is position pointed to the top. So after the pop, like if you want to pop an element, so if the return the element pointed to by top, and we reduce the top by -1. So before pushing, we need to check that if stack is already full. If it is already full, then we print the stack overflow. And before popping, like if we check the stack is already empty, so we need to say that the stack is underflow and it has nothing. So this is the thing, like if first we initialize top equal to -1, and after that we push an element, push 1 and increase the value of top by 1 and top will 0. After that we push 2 and top will increase by 1. After that the similar thing, we push this 3 and top will increase by 2. And after that we want to pop, so after popping it will like it return the top value of the current value of the top 3 and increase and decrease by top 1. So 2 minus 1 equal to 1. So basically these are the two main operation of a stack, pop and push. So let's took some example of like how you can implement a stack in C or C++, Python or Java. So I take you take a look at the Python code. So basically in Python code they uses list. So I give a short intro to the list. Like list are the basically same thing as array, but they can hold any data type or heterogeneous data type in their init, and these are not like the C++ array where you can hold only single data type element, but you can hold any of data type in the list. So first we create this initialize stack. It is a function to create a stack. After that we have the check empty, like it check that stack is empty or not. After that we have the push. So push element basically take the stack and the item, and it append the item and it print the item. So after that we have the pop. The pop will take the stack and it's checked empty, like stack is empty or not, and it will return that stack the element, like the I also say that this list has the pop already implemented, so you don't need to worry about the, and by default it pop the last input, last in and first out property. And so now that's the thing, and this stack it will create this stack or initialize the basic list, and after that we push 1 2 3 and 4 and it will print that. So basically that's the thing. You can also check the C++ implementation, they use the array instead of list. So these are the things that it has all the same thing, a create empty stack and some other properties same as the previous code. So after that we have the stack complexity. So the array based implementation of stack, the push and pop operation takes constant time, like big O of 1, because there is only a movement of a pointer, or we can track the top and reduce it by 1, so it takes constant time. So that's the stack operation. And after that we have the stack application. So stack as some application, like you can reverse a word. So basically it's take last in and first order of the stack, and you will get the letters in reverse order. So you can use it in compilers. So compilers use this stack to calculate the value expression, like its prefix or postfix from. And you also it's seen in the browser, like you have a back button in the browser, so all the URLs you have visited and it's previously stored in a stack, and this type you visit a new page, it is added on top of this stack. So let's take a look like a live example. So if I search for something, let's say I also search for this stack overflow, and after that it will add it to the stack on a stack. And after that let's say I also search stack in Stack Overflow. So now you can see that another page is opened and add to the top of a stack. Now if I press the back button like this, so now it's popped the last input element and its first output, and top will be decreased. Now if I another time pushed it, so now it's popped and go to the home page or initial empty and create an empty stack. So it's a real-time example of a stack in this browser back button function. So in browser, it's a really great thing that we can see the data structure in live action. So I think it's so much great you can do. So I will give you a task from the from like you have a stack, so you have the given an array, so you need to print the next greater element for every element, and you can take help of the stack, and the next greater element of an element x is first greater element on the right side of x is array or elements. If there is no element exist, then you have to print -1. So that's the thing that we have 4 5 to 5. So basically 4 greater is 5, so it is the nearest greater element 5. After that 5 we have 25, and for 2 we have also 25, but 25 we don't have any element nearby, so we print -1 for it. So that's this task for today, and I will make a video that how it is work, because it is already implemented and using stack. So you can do it, and I will see you soon, and thank you very much for hearing me. So and I will end the video here, and please do a subscribe and give a feedback in the comment section. Thank you.